You're standing at the edge of a field just after dawn. The air smells like rain and turns to earth. You reach down and grab a handful of soil, and it crumbles perfectly between your fingers. Dark, heavy, alive. Earthworms slip away. Tiny fungal threads catch the morning light. Now picture that same field 10 years into conventional farming. Same land, same location, but the soil doesn't crumble anymore. It packs. It crusts. Yields are dropping every season, no matter how much fertilizer gets applied. That's not a hypothetical. That's happening on millions of acres right now. And the farmers who are thriving, the ones with the best yields and the most resilient land, they're the ones who walked away from the modern playbook years ago. What they figured out instead is older, smarter, and honestly more surprising than I expected when I first started looking into this. Stick with me, because what these farmers are doing flies in the face of almost everything mainstream agriculture says is necessary. Before we proceed, don't forget to like and subscribe to our YouTube channel. Here's my confession. For 15 years I tilled my garden every single spring, deep, thorough, all the way down. I thought I was aerating the soil, giving my plants a fresh start. Every book I read recommended it. Every neighbor did it too. What nobody told me was that every pass of that tiller was destroying something that had taken years to build. I was shredding fungal networks, collapsing the tiny air channels roots need to breathe, flipping nutrient-rich topsoil down, and bringing dead subsoil up. I was resetting my soil to zero every spring, and then wondering why I needed more fertilizer each year just to get the same results. It wasn't until I visited an Amish farming community in Lancaster County, Pennsylvania, that something finally clicked. The farmer's name was Elmer. His family had worked the same land for over 100 years. When I asked how he kept his soil so productive without the inputs I depended on, he looked at me like the answer was obvious. "We don't disturb it more than we have to," he said. "The soil knows what to do. You just have to stop getting in the way." That one sentence changed how I garden. And I think it might change how you think about all of this too. Let's start at the foundation, because everything else builds on it. Healthy soil isn't dirt. It's an ecosystem. A single teaspoon of living garden soil can contain more microorganisms than there are people on Earth. Bacteria, fungi, protozoa, nematodes, all of them working together in a system scientists call the soil microbiome. It functions a lot like the gut microbiome in your body. When it's healthy and diverse, everything works. When it gets disrupted, everything starts falling apart. Modern industrial farming disrupts it constantly. And the first way it does that is tilling. Every time you till deeply, you break apart mycorrhizal fungal networks, the underground threads that connect plant roots to water and nutrients across wide areas. These networks allow plants to share resources and access things they couldn't reach alone. They take years to establish. A tiller destroys them in minutes. But here's the part that most people never hear about. Soil has layers, and those layers exist for a reason. The top layer is rich in organic matter and microbial life. Deeper layers are far less biologically active. When you till aggressively, you invert those layers. You bury the biology where it can't function and bring up material that hasn't been activated yet. You're not improving your soil. You're sabotaging it season after season. Elmer's family never tilled. They added organic matter on top and let the soil life incorporate it naturally. His topsoil was nearly a foot deep and black as coffee grounds. Mine, after years of tilling, was maybe 3 inches of living material sitting over gray clay. Studies comparing no-till and conventional till plots confirm this completely. No-till soil consistently shows higher microbial biomass, better water retention, more stable structure, and higher yields over time. Not in year 1, but over 5, 10, 20 years, the gap becomes enormous. Now here's where it gets more interesting. Because it's not just the tilling, it's what gets planted and how. Monocropping. One crop, one field, season after season. It's the dominant model of industrial agriculture, and it quietly destroys soil faster than almost anything else. Every plant species feeds different microbes, supports different fungi, and draws different nutrients from the soil. Grow the same crop in the same place repeatedly, and you select for a very narrow band of soil organisms while starving out everything else. The soil community becomes impoverished, vulnerable, easy to collapse under stress. Indigenous farming communities across North America understood this long before modern soil science could explain it. The Three Sisters system, corn, beans, and squash grown together, is one of the most elegant solutions ever developed. Corn provides structure. Beans fix nitrogen from the air directly into the soil. Squash shades the ground, holds moisture, and suppresses weeds. Each plant gives something the others need. The soil benefits from diversity. Yields from all three are actually higher when grown together than when grown separately. Modern agriculture is called that inefficient. You can't run a combine through it. So it was abandoned in favor of monocrops and the heavy chemical inputs required to keep those monocrops alive. And what I found next made me rethink everything I thought I knew about fertility. Masanobu Fukuoka farmed in Japan for over 60 years without chemicals or tilling. He called his approach do-nothing farming, which was misleading. He wasn't doing nothing. He was doing everything differently. His rice and barley yields consistently matched or outperformed his conventionally farming neighbors. His soil, after decades of no-till and zero chemical inputs, was some of the richest in the region. His core insight: nature doesn't need managing. It needs support. The tool he relied on most, alongside the indigenous practices and what Elmer had shown me, was cover crops: rye, clover, vetch, buckwheat. Plants grown not for harvest but for the soil itself. Their roots break up compaction without machinery. They protect ground from erosion over winter. When they die back, they add organic matter directly to the surface, feeding the microbiome from the top down, exactly the way a forest floor feeds itself. Clover alone fixes atmospheric nitrogen into the soil at rates that would otherwise require synthetic fertilizer. One season of clover cover can add 50 to 200 pounds of nitrogen per acre, for free, from the air, while attracting pollinators and feeding beneficial insects at the same time. The science is unambiguous. Cover crops reduce erosion by up to 90%. They measurably increase soil organic matter within 2 to 3 growing seasons. They suppress weeds by shading the soil surface. And they continuously feed the microbial life that makes everything else in the soil function. But what about fertility? If you drop synthetic fertilizer, how do you feed your plants? Composting. And it works at a level most people don't realize. When you add finished compost to soil, you're not just adding nutrients. You're adding a living community of organisms that immediately integrate with the existing soil ecosystem. They produce enzymes that break down organic matter into plant-available forms. They produce compounds that suppress disease-causing pathogens. They build the glue-like substances that create soil aggregates, the crumbly, open structure that lets air and water move freely through the ground. Synthetic fertilizer does none of that. It delivers soluble nutrients quickly, feeds the plant, and bypasses the soil entirely. Over time, it acidifies the ground, suppresses beneficial bacteria, and creates dependency. The plant gets its hit, the soil gets nothing. And a depleted soil community means more disease, more pests, and more inputs every single year. Indigenous farming communities across the Americas, Africa, and Asia have returned organic matter to soil for thousands of years. Not because of philosophy, because they watched what happened when they didn't, and they learned. One more practice that smart farmers never abandoned: crop rotation. Move what you grow. Every season, never leave the same crop family in the same ground 2 years running. It breaks pest and disease cycles. It prevents the same nutrients from being depleted repeatedly. Different root systems work different soil depths, breaking compaction at varying levels without a single pass of machinery. Elmer's family rotated every year. It wasn't a sustainability trend to them. It was just what farming looks like when you're planning to work the same land for the next 100 years. And that's the real mindset underneath all of this. Here's where the two approaches actually split. Most conventional operations till every season. Smart farmers disturb as little as possible, add organic matter to the surface, and let biology do the work. Over 10 years, one approach builds a foot of living topsoil. The other exhausts what little it started with. Most conventional operations grow one crop per field, year after year. Smart farmers rotate through plant families, integrate cover crops between seasons, and think about what the soil needs, not just what the market wants this quarter. The result is a soil community resilient enough to handle drought and pest pressure without constant intervention. Most conventional operations use synthetic fertilizer as the primary nutrient source. Smart farmers compost consistently, use cover crops as living fertilizer, and build fertility from below. Their input costs fall. Their soil's water-holding capacity climbs. Their yields stabilize over time instead of declining. The difference isn't really technique, it's time horizon. Industrial farming optimizes for this season. These farmers optimize for this generation and the next one. Here's your action for this week. Go outside and pick up a handful of your soil. Does it crumble loosely or pack into a ball? Do you see earthworms? Fungal threads? That's your baseline. Then plant one cover crop on any bare soil you have. Crimson clover is easy to find, easy to grow, and will begin feeding your soil microbiome within weeks. You'll see the difference by spring. Now I want to hear from you. Have you tried no-till, cover crops, or serious composting in your own garden? And what did you actually notice in your soil when you did? And also, don't forget to like and subscribe to get more videos like this.